Okay, so let's get started. Hello, everyone. Welcome to the May 2021 OWASP Bay Area Meetup. My name is Siddhartha Rao, and I'm one of the chapter leads here at the OWASP Bay Area chapter. And we are happy to bring you today 3 new speakers with exciting topics. So without further ado, let's get started. Our first speaker is going to be Pankaj Maurya. So Pankaj, over to you.
Hi, thank you, Siddharth. I'll just share my screen. Yeah, I hope that I'm audible.
Yes, we can hear you.
Yeah. So, hey, good morning, good afternoon, good night, whatever region you are in. This is Pankaj Maurya, and I welcome you all to Tangled Web and its same origin policy. I will start with a little introduction about myself. I have been leading Null Chandigarh chapter lead. Null is basically an open security community in India, and right now I am one of the community managers at Null. I have been an active speaker in a lot of communities, and currently I'm also working as security analyst at AppSeco. It's an application security company. This talk is intended for audience, for the people who are new to web security, or if there are students who are looking for your as to start their career in web security, and if you are a professional doing bug bounties, or you're doing web pen testing, and you struggle explaining what is fundamentals of web security, or if you struggle explaining what is same version policy, then this talk is definitely for you. We'll start with a question: what should be allowed? And we'll I'll just read these questions right now, and we'll try to answer these questions at the end of the talk. Again, if you are able to answer these questions, then I'm pretty sure that whatever I have mentioned in these slides, uh, you will yourself say that you understood those things. Starting with the first question: should site A be allowed to link to site B? Should site A be allowed to embed site B? When I say site A and site B, it basically means two different websites here. It can be like Google, or it can be Facebook, two different websites basically. Third question: should site A be able to embed site B and modify its content? Should site A be able to submit a form to site B? Should site A be able to embed images from site B? Should site A be able to embed scripts from site B? And the last one is, should site A be able to read data from site B? Again, it means that should a website A or Google should be allowed to read data from Facebook. Now, before moving forward and talking all about same origin policy, we'll start with the definition, which is really important in this particular talk. So, two pages having same host name, schema, and port can interact with each other without restrictions. When I say host name, schema, and port, let's not worry about them. I have a slide in the future slides where I'll definitely define what these are. Or two pages from different sources or origin should not be allowed to interfere with each other. Again, let's not worry about origin. We'll talk further. Here, when I say two pages, again, I mean two different websites or two different origins, or you can say Facebook or Google. They should they be allowed to talk to each other, or should they interfere with each other? Now, let's try to understand when I talk about same origin policy. Let's try to understand what is the need. Why was this same origin policy implemented inside browsers? So I have here two different analogies. One is from the browser handbook. If you are into web security, you must have, or you might have read this book, the browser handbook. And the other one is uh, I have taken this example from one of the YouTuber, which is Feroz. The first analogy here is hospital patients and their relatives. Now imagine a hospital. You know that in a hospital, all the patients are outsiders and none of them are related to each other. There may be cases, but let's ignore this for now. Now, assume if one patient asks the medical record of other patients inside that hospital from the medical staff, from the hospital staff. What do you think? Will that hospital staff allow reading or accessing medical records of the other patients? No, right? Similarly, think if there is an outsider and he wants to access data or medical records of other patients, then the hospital will deny it. Now, think of our browser with same origin policy. This is how our browser works. It denies cross origin access or data if they are not related to each other between two different origins or websites. Now, To make it more clear, I have another analogy here, which is consider web as an operating system. Now, in an operating system, there is a kernel and there are processes. The job of the kernel is to isolate the processes so that they don't interfere with the memory content, right? Similarly, consider web as an operating system, your browser as a kernel, and the job of the browser is to isolate the tabs, the windows, or you can say different websites from interfering with each other. I hope that it makes sense now. Moving forward, what is a URL? So you see here, there is a, you see this URL, which is https mysite.com1234 page mypage.html and user equal to Pankaj and some fragment called p1. Here, HTTPS is protocol. It can be HTTP also. Mysite.com again is a host name, and 1234 here is port number. In this case, the green color, right? Now we are for this talk, we are only concerned about the protocol host name and port. Okay. One more thing, I have seen people struggling up, about URI. What is exactly a URI? So, as per my understanding, I think URI can be defined as a URL pointing to a specific resource is what we call a URI. In this case, you see the mysite.com points to mypage.html. So, moving forward, what is an origin? Now, we have already discussed that if two websites having same host name, schema, and port, then they are allowed to interfere with each other. And origin is made, you can say, a original tuple made of schema, domain, and port. So in this case, you see there is a schema protocol, host name, and port. Now let's do a quick quiz, which will be basically an open quiz only, and we'll see if the URL which I mentioned above outside the table, that is store.company.com/dir/page.html. Let's see if this URL is in same origin with the URLs mentioned inside the table. So starting with the first, you see there is the URL which is the first URL you see, which is http://dir2/other.html. Now, if you compare the URL with the URL outside the table, this one, the bold one, you will see that only the path differs, which in this case is dir/page.html, and in the table it is dir2/other.html. Now they are in same origin because according to same origin policy, it says that you know um, two different origins having same host name, protocol, and port are in same origin or can be allowed to interfere with each other again. Now the reason here is only the path differs and it doesn't violate the same origin policy, you can say. If you compare the second URL, you will see http store.company.com/dir/inner/another.html. Again, you will see only the path differs and the hostname protocol and the port remain the same. In this case, if you are wondering the port, HTTP by default has port 80. So in both the cases, in the first URL and the second URL, they both have port 80, and they both are in the same origin if you compare it with the URL outside the table. Now, if you see the third URL and you compare with the first URL and the outside URL, you will see that HTTPS, the protocol changes, which is basically a port, and the port also changes because HTTPS has 443 and HTTP has 80. So in this case, the hostname changes. Now, the definition, if you again read the definition, two URLs, having you can say two pages or two URLs having same host name, port, and host protocol, then only they are allowed to interfere. But in this case, the protocol changes, right? Similarly, if you see the fourth URL, you will see the port number changes here, 1234. Again, they are not in same origin and it's in failure. The reason the port changes, the port outside the table, the URL has 80 and this one has 1234. The last, if you see, it is http news.company.com/dir/page.html. In this case, you will see the subdomain here, which is news.company.com. Again, the subdomain changes, whereas the subdomain outside the URL is store.company.com. Moving forward, now whenever you type a website or a URL inside a browser, your browser makes a request to the web server. Your server responds back with some data. The browser loads that data or that HTML inside one of the particular window or tab. and it also creates a context for that particular website. If in this case you consider site A, if you type site.com, then the browser will make a request to the web server, and then it will load the it will give a response back, and then browser will load that response inside a particular context where it can run the JavaScript of site.com, and that particular JavaScript or the context will be isolated from the site B or any other website if you open inside your browser. Now the question is, can site A access site B data? Yeah, the answer is no, because site.com, if you see, if I say http site.com and http siteb.com, the host name here changes and they can't access data because they are not in the same version. Okay, let's do a quick demo here to make it more clear and to understand it easily. I'll change my screen. Yeah. Okay. So this is a example website which I have created just for this talk. And if you type site.com, this is the page which it loads. Now what I'll do is I'll basically I'll try to run some scripts. One more thing. Whatever a website whatever a JavaScript can do to your website inside this page, that particular JavaScript or that JavaScript can also be run inside the console of your browser, which you can find by going to the by just pressing F12 in your keyboard, and you will have this console open. Now what I'll do is just to make my own statement correct, I'll simply type alert, and when I press enter, the JavaScript gives a pop-up which is one with the value one because that's what I passed, and you will see whatever I type here, whatever JavaScript I type here is reflected in the page. Now we'll try to read. Let's try to read the document of it. I'll see. You will see if I say document URI, we are able to read we are basically trying to read the URL, and in this case you will see the URL is cited.com. Now what if I want to read what kind of or what are the JavaScripts which my website is using? In this case, what kind of JavaScript this website A is using or site.com A is using? For that, I'll type scripts. If you open this, you will see there are few JavaScripts, which is browser sync client, jQuery, and bootstrap in.js. You can also go to your page source and you can see those JS being used. In this case, here it is, and you can also see the two scripts being used at the footer. Yeah. What if you want to read the body of this page? Basic JavaScript, which is if you do document.body, you will be able to read the body of your page. In this case, you will see cited.com and the HTML. Yeah. Now to talk about same origin policy, what I'll do is I'll open a window which will contain some different website, and we'll try to read the data of that website, okay, or of that origin. In this case, I'll start with creating a reference. So one thing to mention here is that in a console, if you want to open a different window having different website or a site, then you need to create a reference for that. In this case, if I say go and window.open, we'll use the window object here, and I'll type http. Right now I'll just type cited.com, and you will notice, just let me close this so that it doesn't confuse. You will see the moment I press enter, a new window opens having cited.com. Now, this variable has reference to that particular website. It doesn't matter if it is cited.com. Let's try to read the data of cited.com which we have opened in the second tab. So in this case, what I'll do is, I'll just go and use the variable document.body, and let's see if we can read the data. Body, again the HTML and all. So you will see that we are able to read the data because cited.com opened in the first tab and the cited.com open in the second tab. They both are in the same origin because they both have HTTP. They both are using HTTP protocol, and they both have the same hostname and the port is same. But what if I create a reference and I open siteb.com? Now, if I try to read the data of siteb.com using the same variable, you will see browser gives an fancy error which says permission denied to access property document on cross origin object. Because in this case, the siteb.com, the host name changes here as compared to cited.com. And in this and thus they both don't comply with the same origin policy, and that is why the browser prevents reading the data of siteb.com. I'll try to make it more clear. If you are still confused or if you're totally new to same origin policy, I'll use fetch API, and we'll see that. So fetch is basically a kind of API which you can use to make request to a different to some origin, and then you get the response, or you download or that response is being downloaded as part of the response, or the data is being downloaded as part of the response. So if I say constant var1, let's type again, what I'll do is I'll type cited.com, and we'll basically make a GET request, and we'll see if we get the response of fetch API, or the fetch API gives us the response. You will see our request is made and a response comes with status 200 OK. You see this, right? 200 OK. In this case, because cited.com again, for this particular console where website A is loaded, cited.com which we made the request is again in the same version, and they both comply with the same version policy. So browser allows you to make a request and fetch the response. But what if I create another variable here and we try to read the data of siteb.com? You will see the browser itself says that cross origin request block, the same origin policy disallows reading the remote source at siteb.com. If you really want to make a cross origin request, then you need to use some header like course header, which are some custom headers which you implement, and you are able to read data cross origin. I'll talk about this later on. Yeah, I hope that this is clear now. I'll switch back to my slides. So now we'll learn that siteb.com and siteb.com, if you have opened in your browser two different tabs and they both contain siteb.com, like website and website A, then you are able to read data or interfere with each other, you can say. But if it is siteb.com, then you won't be able to interfere with the siteb.com. Now let's talk about how does same origin policy works in browser tabs. So let's assume that this browser, if you see this picture here, this browser has 4 different tabs and they all contain some different websites. What I've done here is I have again created a reference and used that window object, which you see window.open, and I have created a reference with site C. Now, one cool thing to notice here is that whenever you create a reference, our back reference is created, which basically means that our reference is created back to the origin website. For example, in this case, when you create a reference from website A to website C, then website C has also a reference back to your website A. Also, if you read the note, when two document sites do not have the same origin, which in this case, website A and website C, JavaScript API like window.open, window.opener allow documents to directly refer each other with very limited access to window and location object. This is a definition and a statement made by Mozilla. It basically says that when you don't have a direct reference, or when the two different sites or origins are not in the same origin, then your browser or your JavaScript APIs like window.open or window.opener can be used, and they will create a direct reference with each other with some limited access. In this case, it can be like window or location objects having some limited permissions to perform some limited actions. Now, when you create a reference, there is an attack scenario possible here. That is, this website C, because it has a reference back to your website A, the origin website, it can replace the website A origin with some bogus or some phishing page, and you might get tricked, and you might end up, for example, in this case, if you have opened site.com in the first app, and site C uses this window.opener location replace and replaces your website with gmail.com, let's say, and you might see, oh, and then your website will be replaced by gmail.com. Now what will happen? You might think that, oh, I might be logged out my Gmail, and that is why I see the Gmail page, but that Gmail page belongs to a phishing page, basically phishing website created by an attacker. Now if you enter your credentials, true credentials of Gmail, those credentials will be fetched by the attacker. Let's do a demo again and see how this works. So what I'll do here is I'll switch back to my browser. Oh. And I'll again create a reference, and we'll see Bob1 is equal to window.open. You see that we opened a website which is site A, or it can be, let's open siteb.com. Now assume somehow attacker has a reference to your website, and in his browser, or you can say in the other tab, attacker uses the window dot look it uses that object window dot opener dot location dot replace, and try to replace your origin website. In this case, one more thing before I talk about that. Now if you try, because we have a reference here which says bob.window.object.com, and because I already mentioned, if you try to read data of siteview.com, you won't be able to. Similarly, if you try to read data of site.com, you won't be able to read the data again, because they are not in the same origin. But let's try to replace the location replace. Yeah, let's say if I type gmail.com, you will see the moment I press enter, the website A, the location of website A will change to gmail.com. Now if you if you are a user and you are sitting on your computer or browser, and you realize that, oh, there's a Gmail page, you might end up entering your credentials and giving those credentials to an attacker, because that page belongs to a phishing page. And because they right now this is Gmail, but an attacker can pass its own URL having some random URL having a Gmail page cloned there. I hope that it makes sense. And yeah, one more thing to do here is, if I just go to site.com, and if you realize, if I create a reference again, bob1 is equal to, one second, window dot open, or it can be any other website, let's say siteb.com only. And now let's try to modify the content of siteb.com. In this case, I have this variable here, so I'll say document.body dot bob is not defined. Stream is equal to OWASP. Now what I'm trying to do is, I created a reference again, and this time I'm trying to using the inner HTML, which basically whatever you pass as the value, that particular thing will be written on your in the HTML. So when I press enter, you won't be able to do this, because again the siteb.com is a different origin, and you can't write, you can basically reference, but you can't write data to that particular page, or you can't interfere with the HTML of that page. Okay, getting back to my slide, just wanted to cover this. Yeah. Now, how does it apply? Same origin policy, applies to anchors. In case of anchors, assume that there is a browser and it has two different websites, whereas site A, siteb.com. Site A has a reference, or you can say is using an anchor tag and h reference and has a link to siteb.com. When you click on that link in siteb.com, your browser will make a request to the site B server, but the response will load into a new context, which means that the browser will, your site.com will won't be able to read the response in the same context. The browser will create a new context and it will, replace the site.com with siteb.com. So if you see conclusion, any site can link but can't read the response in the same context. If you are not a developer and if you're thinking what is when I say anchors, so it is a h reference is equal to http siteb.com, and thus you can create a link to siteb.com. Similarly, it applies to forms. When you If you have a form at site.com and that form, every form has something called action attribute, and that action attribute has some URL. In this case, if that URL, let's say that URL is pointing to siteb.com, the moment you post a successful form, which means with the moment you submit a successful form, a post request will go, and the response again will load into a new context because of the same origin policy. And maybe your origin website will be replaced by the siteb.com, but you won't be able to read the response in the same context of siteb.com. If you are if you are submitting a form using JavaScript and you make a request, you will see that when the response comes, your website A will be replaced by website B and your console will be totally empty. When I say console, I basically means the browser developer console. How does it apply to CSS? Again, if you are a Bootstrap user or a developer, you might have seen a lot of people using Bootstrap CSS style sheet, basically cascading style sheet, to give colors to your, to give fonts, different designs and colors to your page. That is why we use CSS. Now, a website can embed CSS or cascading style sheet from another website or another origin, but you can't read the, honor rules or some kind of metadata which is related to that CSS. But you can definitely embed the site CSS of another origin. That is how same origin policy works in this case, in the case of CSS. How does it applies to JS, JavaScript basically? Now you can say there is an exception here in this case. JavaScript, any website can, you can embed JavaScript from any other website. Like if you are a Bootstrap user, you might have seen people embed jQuery basically inside their footers, and which is again not a good practice, because if you don't trust that particular other origin from which you are embedding the JS, then if that origin is a malicious user or some malicious website, it might run or perform malicious actions on your site.com, on your website basically, and it might lead to attacks like cross-site scripting and all. Why people use it? It is used for ads, tracking scripts, and jQuery scripts. If you see the examples, few other exceptions here. You can embed images from different websites. You can embed scripts, which I just mentioned. You can embed style sheet, which is really an exception if you see, because you are able to use the features of that different style sheet which is being hosted to some other website, which is basically cross origin. Yeah. If you want an example, you can go to getbootstrap.com and you will see getting started page, and you will see a lot of CSS and JS related URLs which you can embed into your website if you're developing a new website, and those you will see that are different from your, those have different origin from your own website. Now, how does it applies to browser? Web storage. Browser has two kinds of storage, you can say, local and session. There is something called cookies, but let's talk about local and session right now. Local storage is persistent. When I say persistent, I mean even if you close your window, that token or whatever value will be stored inside the that key and its value, that will remain there even if you again close the window and again open your browser. And it can be shared between the windows. Let's say that if there are two tabs open inside your browser, cited.com and cited.com, then they both can share the or use the local storage, because the token, whatever token is stored inside the local storage, because they both are in the same origin policy, or they both are in the same origin. Now talking about session storage, these are non-persistent. They only apply to the active window. The moment you close the window, the session gets destroyed or logged out or expire. Now web storage follows the same rule of same origin policy. Browser does not allow two different origins to access each other web storage. If you again, if you are not well familiar with what I'm talking about here is, then I have just for this talk, I have also created a documentation around the whole talk, which is right now hosted at talks.pankajmora.com. And if you go to this place, you will see the latest talk, which is Tangled Web and its same origin policy. And you can browse to this documentation, and you will definitely find what, when I say web storage, what I'm talking about. I have given detailed steps here, that how you can check if same origin, how does same origin policy applies to web storage, and you can follow the steps and you can practice it hands on. I'll definitely share the URL at the end of the talk also. Getting back to the slides. Yeah. Now, how does same origin policy applies to cookies? Now, in case of cookies, cookies were created way before same origin policy was created, and that is why cookie follows its own rule of, whereas when you know that same origin policy follows host name, protocol, and schema, but in case of cookies, it follows name, domain, and path. Now you can say cookies are more specific and less specific, because two different websites having same origin, if you embed inside if you embed one website inside the other, and if they both have same origin policy, then they can read the cookies of the parent website, you can say, which is embedded in, which embeds the second, the other website inside an iframe. Cookies are less specific because different origins can mess with the each other cookies. In this case, if you see attacker.cited.com can mess with the cookies of, can set for cookies for cited.com. Now it works same for the iframes. If a website has two different iframes, then again website A won't be able to or interfere with website B, or parent website can't interfere with website A or website B, because they all are in different origins. For example, cited.com is the different origin, siteb.com is a different origin, and parent site.com is different origin. Now getting around same origin policy, let's talk about ways to how you can get around same origin policy. In this case, once again, yeah, getting around same origin policy. Again, there are ways by which you can find a way to bypass the same origin policy. You can say by feature, or you can say you can opt in ways to get around same origin policy. In this case, the first is JSNP. This is basically, it uses a function to which via which it can load data cross origin. Now the second one is XHR with course. By default, if you make a request, or XHR is basically XML HTTP request, and you use it to make get request and you get the response and all. By default, when you make a request using XHR, that is XML HTTP request, you can't read the data cross origin. But if you use cross origin resource sharing headers, custom headers like access control allow origin, then you can read the data. What happens in this case, when you implement a custom header, when you make a get request, the request goes to the server responds back with a custom header, which is access control allow origin, and it gives the name of that site. That is, in this case, if it is cited.com, then then the browser says, or the response says to the browser that let cited.com access the cross origin data.
Hey,
URL fragment.
Pankaj,
Yeah,
sorry to
yeah.
interrupt. Just a timing reminder that we have 5 minutes left for this talk.
Yeah, sure. The second is URL fragment. This is an all way of doing cross origin request, but it is very limited, and you can't do more using this using this URL fragment. Next is postMessage API. postMessage API enables you to do cross origin communication. It can be between a page, pop-up between a page and an iframe. Now, to implement postMessage and to have a cross origin communication, you need to have some kind of reference to your page or to that frame. For example, it can be a website embedding a different origin inside an iframe, and thus you can have a reference. How does it work? It has a post message and a listener, where post message sends the message and listener listens for the message. And again, post message API has some limitations, like you can, let's say that there is a website called store.site.com and it is listening for messages from login.site.com. So whenever you log in, the username, let's say that username goes to the username is posted as a message and the listener listens for the message. Now there is a, now this is not secure. The reason, because if you are sending messages, posting messages without defining an origin, because in this case, if you by default, if you just pass asterisks and you don't define any particular origin, then any other website, can embed, or let's say an attacker can embed that login.site.com, and because login is just sending the messages and looking for any parent to listen for the messages, it might send the messages to the attacker. Now this is the high level way of explaining the limitation. There can be, basically depends on the implementation of the code, how it works. Again, so what you can do for this, you can basically do the validation of the destination. So it can be like, you can define a proper destination, that this message is specifically for the store.site.com. Now another insecurity here is that if that store which is listening for messages, if you do not define the source of the message, like from where you want to listen for the messages, then an attacker can again embed the store.site.com, and it can post some bogus data which store.site.com will listen, and it might accept this as the message. So what you can do here is, you can validate the source by specifying a particular source, like in this case it can be login.site.com. So it will only listen messages from, so the store website, right, it will only listen messages from the login.site.com. Now the last slide, again, let's try to answer that what should be allowed. If you remember the slides now, so let's try to answer it. Should site A be able to link to site B? If you remember, we had an anchor tag wala slide where we linked site.com to siteb.com. Yes, we can. Should site A be able to embed site B? Yes. Should site A be able to embed site B and modify its content? No, right? Because if you remember, we try to use inner HTML and modify the content of the siteb.com. So the answer is no. Should site A be able to submit a form to site B? In this case, yes, but you can't read the response because the response loads into a new context. Should site A be able to embed images from site B? In this case, yes, again, but you can't read most of the metadata from it. But yes, it is an exception, as I mentioned in one of my slides. And you can dig more about how the web or browser works while embedding static things like images, CSS and all, movies and all. Should site A be able to embed scripts from site B? Yes, it can. Should site A be able to read data from site B? No, right? Because they are in the different origin. So yeah, thank you. If you want to follow the documentation for practice, I'll also upload all the code of my lab which I've created for this lab, for this talk, over GitHub. And this is the URL for my documentation, that is talks.pumpkinmora.com. And you can also reach out to me over Twitter and we can have the questions now. Is that
Awesome. Thank you, Pankaj. Are there any questions for Pankaj before we move ahead into the second talk?
I see one question here. It says that if the embedded site gets loaded into a different context, how is access possible? If you remember the slide where I mentioned, that exception thing, right? That JS, when you embed JS, in that case, because the JS has an exception, and same version policy for the JS, it is an exception where it allows you to embed scripts from other website. And if you trust that particular website from where you are embedding the scripts, then it is okay, because then even if it is malicious, then you are responsible for it. But if you do not trust that website and you are embedding any random script, then that particular website can perform any scripting action or any cross scripting attack, depending upon the context again, that how the attack executes, or what is the context of that? I didn't get your question here. Is the trust provided by course? I mean, no. Again, when you implement course, you just say, I'm not talking about here JS now. When you implement course basically says that should you be allowed to, should you be allowed to read the data cross origin? Basically sharing of data cross origin in this case. Whereas for JS, if you are embedding, then you are responsible for it.
Okay, Pankaj, thank you for taking those questions and answering them. Let's move in our second talk here from Timothy. So Timothy, over to you.
Thank you. Let me go ahead and start sharing the screen. Hold on, I think I've got the wrong one shared. Hold on. There we go. All right, so today we're going to be talking about the new NIST SP 800-53 revision 5. I'll talk about what that is if you're not familiar with NIST and with the standards. It's really a framework that government institutions and a lot of enterprises use for both security and for privacy. And what's interesting about this is the new standard now has both RASP and IAST included for application security, which is a first in this particular standard. And we'll talk about what RASP and IAST are in case you're not familiar with those terms as well. So we'll go into a little bit of detail about this. First, why did this change? What was driving the need for RASP and IAST to be added to the standard? And what's interesting is if you look at the US CERT vulnerability database that basically NIST keeps track of, there have been more vulnerabilities being reported in code that's been released to production over the last 4 years than there's ever been before. We actually had record highs for 4 years in a row and we ended 2020 with 18,352 vulnerabilities reported, the highest ever. And this year, while we're not quite on that track, as of yesterday, I actually went and looked at the numbers yesterday, we're somewhere between the 2019 and 2020 numbers right now. So we're a little less than the 2020 run rate, but we're still really high in terms of the number of vulnerabilities we're detecting this year as well. And it's of course super important because these vulnerabilities are the ones being targeted by cyber criminals. These are the ones that are of course leading to the data breaches that we hear over and over again. And these are the ones that are of course zero-day attacks. These are the new vulnerabilities that basically new attacks are being dreamt up of. And if you look at why that's an issue, it's an issue because 70% of zero-day attacks make it past the security mechanisms we use today. And that's probably one of the big driving forces for getting RASP and IAST into this new standard. So if we look at the standard itself, it's called SP 800-53. It's been written by NIST, which stands for the National Institute of Standards and Technologies. If you're not familiar with NIST, NIST is a US government institution that was started in the early 1900s, really around setting standards for weights and measures and things like that. But their purpose and their evolution of what they do has evolved quite a bit since then. They now set the cybersecurity frameworks for security for governmental institutions. And so there are actually a number of frameworks that they produce. This is one of them. This one in particular is called the Security and Privacy Controls for Information Systems and Organizations. It was first created back in 2005. And so it's got some amount of time under it at this point, obviously with 16 years, but it's also been evolving. They've actually created multiple versions of this and updated it continuously. The most recent revision before this one that just happened last year was back in 2013. So it's been 7 years since they did an update. And so the most recent update started back in 2017, but was finally released in September of 2020. And you can see the definition here. It's really, it's a catalog of what they call security and privacy controls. And it's for any type of organization. Primarily, of course, it was developed for US government organizations. And in fact, US government organizations typically have a requirement to adhere to and use these types of controls that are specified in the document. And so if you look at the changes that happened in this most recent release that happened in September, a lot of it was really around privacy, actually. There were some changes, as I mentioned, about application security, but if you look at their blog article that they wrote about the changes that they made to SP 800-53, and you read about their press releases and things that they wrote about it, it had a lot to do with privacy. And so the focus was initially around getting the privacy controls updated. And then the other big thing that they tried to do was to de-emphasize the federal focus, meaning that they wanted to make sure that these controls were more accessible to enterprises so that enterprises could start adopting this as a framework as well. And what's interesting about that is that it's already estimated somewhere between 30 and 50% of enterprises already used NIST SP 800-53 as a framework for their security and privacy. So hopefully this will drive that more, and more enterprises will start making this the framework that they use for their security and privacy. So as I mentioned, the new revision 5 was finalized back on September 23rd of 2020, and it did include 2 different updates for application security. It added a requirement for RASP, which stands for Runtime Application Self-Protection, also sometimes referred to as Runtime Application Security, and it added a section on IAST, which stands for Interactive Application Security Testing. So both of those were added to the framework itself. And both of those are, of course, application security mechanisms to help you get your applications more securely to production. And if we look at how that actually evolved, meaning why they're the latest in application security in terms of technologies, you know, when we started doing application security, a lot of organizations said, hey, it's enough just to do system or operating security and just have antivirus or anti-malware, and today EDR solutions to protect that application. And then of course it got to the point where, well, no, we also need network security. We need a firewall or a web application firewall sitting in front of that application as well. But both of those have now evolved to having a specific category called application security, just because those threats, the breaches of course continue, and the attacks on applications themselves continue to grow more and more. It's actually estimated from that Verizon breach incident report that comes out every year that 40% of attacks are on specifically vulnerabilities within web applications themselves. And that's really the driving need for having specific security just for applications. So if we look at the RASP requirement that's actually in the SP 800-53, it's in, as you can see, this document in the section SI-7. It's for the section that's related to software firmware and information integrity. And they added a subsection 17 that's titled Runtime Application Self-Protection. So the whole category is actually referred to as RASP. And then if you look at the highlighted part, it actually says, hey, this differs from traditional perimeter-based protection, meaning that you need this even if you have a firewall or a web application firewall, because it's actually doing something that the firewall and the web application firewall don't do in terms of protecting your application. Similarly, IAST got added to a section called Developer Testing and Evaluation, and it was added in subsection 9 called Interactive Application Security Testing. So once again, around the entire technology field has its own subcategory. And here highlighted, you'll notice I have highlighted observing applications as they run during testing. And this is key for this particular technology in terms of actually having the visibility into the application itself while they are running in production, while they're being tested. And I'll talk more about how this differs from traditional testing methods in a second, but that's really the big benefit there and the big difference with IAST. A lot of times when I give this presentation, I get asked, well, if I'm a government institution, when do I have to comply, or do I need to be in compliance with NIST SP 800-53? And there's actually a document from the OMB, the Office of Management and Budget. It's called Circular A130. And it basically says that if you are required to adhere to the NIST SP 800-53, you do need to be in compliance within a year of the release of the document. And so Since this document came out on September 23rd of 2020, that means as a federal agency, if you are required to have compliance, you do have to have it in compliance by September 23rd, meaning that you, of course, would have to be using RASP and IaaS as part of your application security platform. There is another option, though. If you're a federal agency, you can also request a waiver from the standard. That is actually not that uncommon, so that is your other option if you do need to be in compliance, is you can go ahead and ask for a waiver. There is one exception, though, which is I thought interesting, is that if you have a system that's currently in development and it's going to release prior to the 1-year date, meaning that it's going to come out before September 23rd, but after September 23rd of 2020, but before September 23rd, 2021, it also needs to be in compliance upon the release or request waiver at that point as well. So that's the timing and requirement for the federal government. If you are in enterprise, obviously you don't have to adhere to these dates. Enterprises can set whatever date they want for adhering to the new release. And then of course, you know, who should care? Obviously the federal contractors should care. There is also a requirement, in case you're not aware, if you are an enterprise that works with or has a contract with the federal government, you may also be required to go ahead and be in compliance with this as well. So just be aware of that. Some enterprises, just the ones that have are contractors to the federal government, may have that requirement also. Okay, so what about RASP? What is RASP? If you look at RASP itself, it was introduced back in 2012 by Gartner. And so it's not a new technology. It's been around a while now. The idea of RASP has been around since 2012. It was actually highlighted in 2014 at the Gartner Security Risk Management Summit. So that's when it started getting more visibility as a solution. And I see that there's a question. I'm gonna take this one real quickly just to answer it. It says, this person says they evaluated RASP a couple of years ago. Solutions were still kind of immature. Have they improved significantly enough to be a requirement? And that's actually a great question. They have changed quite a bit. RASP solutions are I want to say there are more of them available, and they are much more sophisticated than they have been in the past. I'll get into some of that in a little bit when I talk about how RASP is implemented and what it means to implement RASP and why some of them have been a problem. But we'll go into that in just a second. But the idea behind RASP and what RASP is, it's a security platform that runs directly on the server and protects the applications that are running on the server. So a RASP solution, rather than being an edge solution like a WAF or a firewall, actually resides directly on the application server. It's typically what's called a sidecar application that sits next to the application and protects it. And as the name of the category implies, from runtime application self-protection, it's actually protecting the application. It's actually providing what's also known as virtual patching for the application itself. And it's part of the broader category that the analysts, if you talk to any of the analysts that are out there, it's part of that broader category that's called application security. Okay, so the way most RASP work is, of course, they have to deploy an agent. You have to have an agent on the application server. That's what it's referred to. The runtime application self-protection piece is that agent that's running on the application server itself. Most of them also, of course, have a second component that's a central management portal to go ahead and manage all those agents. And typically those sit behind a firewall and a WAF. So by having a RASP solution, it doesn't mean you're getting rid of your firewall or WAF. For most people, it means working in conjunction with the firewall or the WAF that's protecting the application already. And of course, then it's in normal operation, your daily runtime. It's there continuously protecting the application. And of course, dealing with the traffic from the valid users and the attackers. So how does RASP work? It works as an agent, as I mentioned, but it has to have visibility into the application itself. It's got to be able to see what's happening in the application. So if you look at RASP solutions, there's one of three methods that they use to get that visibility. The first one is something called the overhead layer. And this is the one that is basically very similar to what APM vendors use today. So if you're already using an application performance management platform, then you probably are already familiar with this overhead layer method. And basically the way it works is it's intercepting calls to and from a runtime environment like Java, for example. And it can attach into your application either dynamically or statically. And basically using that static or dynamic attachment using a jar file during the JVM runtime is how it gets visibility and seeing the code as it's executing in memory. There's a lot of benefits to this. One, of course, is the visibility. Two is the fact that you don't have to actually change the Java code in the application itself, so that you can leave the code itself. You're just modifying the JVM as you start the code. So that's the method one, that's the overhead layer. And that's probably actually the best way to do it. And in fact, it's the way that, as I mentioned earlier, APM vendors get that visibility. And there's a reason they do it that way, obviously, for the same reason. Method two, using a specific RASP library and SDK. This one has a bit more of overhead, and this actually was the way a lot of earlier RASP solutions did it, in reference to the question about early RASP solutions, meaning that there was specific libraries that you had to write into your existing application. So this meant rewriting code, and this meant that it would have a heavy performance impact on your application. So this was some of the reasons that the earlier solutions seemed immature and seemed problematic, was they did have to actually rewrite code in order to make them work with RASP. And so that's another method to get that visibility, but obviously a little more complex in that requirement of having your own separate library and SDK. The third method is called embed using application language. And the way this works is, yes, you still have a RASP agent residing on the application server, but rather than intercepting calls from the runtime environment or using a library, it's actually just looking at the web requests and responses. So essentially, it's the same as your WAF. It only sees the HTTP requests and responses coming from the web server, and it's reacting based on those web requests and responses rather than actual visibility into the application itself. So it has less visibility than what an overhead layer or a RASP library would provide. And so in that method, while it may be lighter weight, it isn't seeing as much of what's actually happening within the application. So that's the downside to method three. But the upside, of course, is that it's lighter weight in the effect it's going to have, because it's only looking at the web traffic. So those are the three methods. Obviously, we recommend overhead layer because that is, as I mentioned earlier, what an APM vendor uses and gives you the visibility that you would need into the application itself while remaining lightweight. So it's basically the best of the other two methods. All right, and then if you look at RASP technologies themselves, there are, as I mentioned earlier, quite a number of RASP vendors, and they all actually use slightly different technologies in how they determine what's actually an attack that's happening on an application. So a lot of these you're probably familiar with. You've heard about different security technologies in use by all the other vendors for their endpoints, for network, et cetera. You've heard about signatures and patterns being used in standard antivirus, anti-malware. You heard about the move to heuristics and fuzzy logic, and now, of course, the use of things like machine learning and AI. And of course, behavioral analysis is another one of those new ones. And then this last one, deterministic security. This is probably one of the newer ones that's being implemented. What I'll mention about all these technologies, just to be aware of, is if you look at signatures, patterns, heuristics, fuzzy logic, machine learning, and AI, the first four on this list, all four of those technologies really rely on looking at an attack that has already happened. Machine learning, for example, takes data sets of prior attacks and then trains the machine learning algorithms to learn from those to detect a new attack. And so what that means is all four of those top technologies are really just looking at variations of attacks that have already happened. And that's actually problematic, because what happens is if you're only looking at a variation of a prior attack, you're going to miss an attack that is completely new. And so that's actually a downside to those technologies, meaning that those are the ones that are missing that 70% of zero-day attacks that I mentioned that make it past the security mechanism. So that's actually part of the problem with the security technologies that are in use, not only by RASP, but by WAF and all the other technologies that are out there. The fifth one, of course, behavioral analysis here. doesn't rely on prior attacks. It relies on actually studying the behavior of your application and trying to figure out what normal behavior looks like. That in itself has a few problems. Obviously, the big one is that it takes a long time. If you've ever used any type of behavioral analysis method, you've probably already looked at the fact that it probably takes weeks, if not months, to train. And then if something normal doesn't happen within those first 3 months that you've done the training and happens after because it's a rare occurrence, well, then it gets triggered as a false positive. So behavioral analysis has two big problems. One is long training time, and two is false positives are easy because anything that doesn't happen normally, or I should say happens rarely, gets triggered as a false positive. So that's a problem with the fifth one. The last one here is kind of interesting. Deterministic security has to do with actually validating the code as it's running. It's actually making sure the code is running the way it's supposed to, because we now have that visibility into the code as it's executing in memory that I talked about, because we have that instrumentation of the code that's possible because we're sitting directly on the application server. And so deterministic security is probably the one technology out there that can help avoid the false positives, as well as detect a true 0-day because it's not relying on a prior attack. So that's another one that should be investigated when you're looking at RASP technologies. But all of those are technologies that are in use. The technologies out there might use one of them or some mix of them, but just be aware that those are the ones that are being used at this point. And then we talk about what types of issues are being addressed by RASP. And I mentioned earlier, you may still need your WAF and the reason in your firewall. And the reason for that, of course, is you still want protection for network-based attacks, things like denial of service attacks. And that's where your WAF or your firewall will help you. But there are problems that are addressed specifically by the RASP solution. And one of them, of course, is protection for the OWASP top 10 web application security risks. That's the well-known one. It's the name of the group here that we're talking to. So that obviously is one of the primary things that you would be instituting a RASP solution for. Memory-based attacks, 0-day attacks, as I've been talking about, and then of course doing this in real time to protect the application as it's running, and then be able to virtual patch. This is probably the important one here to talk about, because what's going to happen is, of course, is some vulnerability is going to be discovered in an application. It'll be, reported to the vendor that has that software solution, and then when they actually come out with a fix, they'll report it to the NVD database, and then, of course, then you as an administrator, if you're taking care of the application, has to then patch it in production. Well, the time from when it gets released to the NVD database and the time that you get to patch it is typically going to be some long time period. In fact, it's estimated it can be up to, on average, 280 days before it's actually patched after the release of that vulnerability information. So what do you do in that 280 days between the time the patch was released and the time you actually patch it? Well, you've got to protect the application in some way. And virtual patching is what does it. By having a RASP solution that does virtual patching, you're actually then protecting the application without having to have it patched and protecting it from being attacked or exploited in that method. And that's the big benefit to RASP. And that's why it's been called runtime application self-protection, because of that virtual patching capability. And then, of course, if you're looking at a RASP solution, you have to make sure it's supporting everywhere that you have an application running. So you do need to make sure it supports your languages, as well as your servers and your infrastructure, whether it's virtual or containers or Kubernetes or serverless or AWS, Azure, and Google. All of those infrastructures should be supported by your RASP solution. All right, I'm going to switch gears now and move over to that IAST real quickly and really talk about where that came from. So if you're on the pre-production development security testing side of application security, you're probably already familiar with SAST and DAST. SAST, of course, stands for Static Application Security Testing, really analyzing the source code at rest. It's what's also referred to as white box testing. The big complaints that we hear about with SAST, of course, is that it's slow and that it has false positives. And the other one that I actually hear about is how do you actually tell that the results are real, meaning in addition to false positives, but how valid is that vulnerability that it discovers? Meaning, is it actually exploitable, or is it just informational, or is it just low risk versus high risk? So SAST does have some issues but it's one of the more commonly used security testing methodologies out there, obviously. DAST is the other one that's out there, standing for Dynamic Application Security Testing. It's what's called black box testing. And basically the idea, is that you are running your code and you're then sending attacks to that code. So your application is running as an application, and it's basically simulating attacks on your application. The big issue here, of course, is that it doesn't see what's actually happening. It doesn't see what's actually happening in the code itself. It only sees, as I mentioned earlier, like firewalls, it only sees traffic coming to and from the application server. And so it hasn't got the same visibility that something residing on an application server would have. The biggest issues that we hear about with DAST from our customers is really, one, it takes a long time to set up a DAST scan because there's a lot of knobs and configuration and tweaking just to set up a scan. And then two, the scans themselves take a long time. We've heard on average from customers that it takes not only days, but sometimes even weeks if the application is big enough before you get a result back from the DAST scan. And then you've got the same issue with false positives and ranking of vulnerabilities and proving that vulnerabilities are actually exploitable. Those are the primary issues around DAST. So while those are traditional methods, they also have their downsides as well. And of course, we are always looking for a better solution, and that's really where IAST came in. And so IAST stands for Interactive Application Security Testing. And it was really designed to overcome the limitations of both SAST and DAST. And there are actually two different kinds of IAST out there on the market today. There's something called active IAST as well as passive IAST. Active IAST is basically DAST running with a RASP agent. So it's an active attack happening on your running application while you run an agent directly on the application server itself. And so the agent is then monitoring and looking at the application the way the RASP would to detect whether or not any of those attacks coming from the DAST are actually successful, and if anything's actually happening in the application in terms of a vulnerability being exploited and so forth. The benefit here of having that agent while you're running that scan is that visibility, and having that visibility then means that you can get things like where to find the vulnerability in the code, and then getting the whole proof of that exploitability, because now you've got that visibility into seeing that it was exploited, and then the IAST can then provide that back as proof that, hey, I was able to exploit that vulnerability in your application. Passive IAST is very similar. The big difference between passive IAST and active IAST is passive IAST doesn't require an active attack. What passive IAST does is it also uses an agent directly on the application server, but rather than using an attack scenario, it just uses your normal QA activities. So you would go ahead and continue to just do functionality testing on your application. And then a passive IAST would then basically be looking at the code being exercised in the application by that normal function. And then it's basically fuzzing to see if there's any vulnerability in the code itself that can be exploited based on that QA activity that's happening. And that's what passive IAST is. But because it also has that same visibility, it can give you the same level of detail that the active IAST can give you as well. And that's the big benefit to IAST. It's the visibility in the application, giving you exactly where to find the vulnerability and giving you proof that it's exploitable, that whatever vulnerability it finds is really a vulnerability and not just informational or a false positive in that respect. And because of that visibility, IAST solutions tend to have less false positives. And so one other way to do this, of course, is to use a RASP, because there are so many RASPs out there, as I talked about. If you use a RASP directly with your existing DAST scan, that's another way to get the same type of IAST results. So if you just stick a RASP agent directly on your application server, you continue to run your DAST scan the way you've already doing it, and that you're already running it. Since, as I mentioned, most organizations are running a DAST scan already, then you can get correlation between your RASP report of attacks with your DAST scan, and you can verify vulnerabilities by getting the proof of exploit and the location of the vulnerability, as well as find additional vulnerabilities that the RASP agent will see that your DAST scan won't. And then you can even find false positives because the DAS scan will report on vulnerabilities that aren't found by the RASP. All right, one last real quick view of a comparison between the DAS in terms of what you would get from a DAS versus an IAST. This screen output on the left is a DAS report. It's from one of the big vendors out there that does a dynamic application scan. And it's basically saying that it found an SQL injection vulnerability. It tells you the URL at the top. It tells you what it injected to be the payload. In this case, it was -1839 or 1 = 1. The 1 = 1, of course, is the very common, well-known SQL injection vulnerability. And it tells you what it posted as an HTTP request to get that SQL injection to work. That's not a lot of information about your code. It's not a lot of information about where to find the vulnerability in your code. And if you look at what a RASP solution actually provides while you run that same attack, it will give you everything that around the incident, around the container node, wherever it's running. It'll also give you information about the attack, the application name, the port, the PID of the running app. And it'll give you a file name. It'll give you a line number where to find the vulnerability. And then rather than just give you the injected payload, you see below that, we're giving you the full SQL select statement that would be used. And then, of course, we also give you the full HTTP request as well. So a lot more information than what the standard DAS scan gives you. And of course, giving you these basically IAST reporting directly out of your DAS scan. And that's what IAST would give you as well. So that's the benefit to running IAST. All right. That is my introduction to NIST SP 800-53 around RASP and IAST as those requirements. Just so you guys know, I'm from K2. K2 Cybersecurity is a company located in San Jose, and we do application security. We do RASP and IAST solutions. And with that, if you've got any, if you're interested in hearing more about K2, you can go to k2io.com. But with that, that's the end of my presentation, and I'll go ahead and take questions if anybody has any other questions about RASP, IAST, or about the NIST SP 800-53 revision 5 requirements. All right, I don't see any questions right now, but you can go ahead and type them into Q&A. I will add one more thing that I didn't talk about during the talk, and that's because of the question that came up earlier about the solutions being immature. I'll mention also that the solutions that came out earlier were immature because they tended to be very heavyweight, meaning that the agent that was running on the application server used up a lot of CPU memory or disk space and added a lot of latency to the running application. And that, of course, is really problematic because you obviously don't want to add any latency at all to an application if possible, because it will make it unusable. And so, for example, the agent that comes from K2 is super lightweight and adds less than a millisecond of latency to a running application. And that's one of the big differences probably from the earlier RAS solutions that are out there, is just the amount of impact that they would have on a running application. Given the approach to IAST leverages RASP, does this meet the SP 800-53 requirements, killing two birds with one app, so to speak? Yeah, actually, if you run a RASP solution with your IAST, that is essentially running IAST at that point. In fact, some vendors like K2 do both with the same product. We do both IAST and RASP using the same technology and the same product. All right, any other questions? Is the NIST standard supposed to serve as advice to self-motivated companies or as a set of requirements to enforce some level of minimum security? And so really the NIST standard is, as I mentioned earlier, is really for the federal government, because the federal government wanted their agencies to have some common level of standard across the board to ensure that they're meeting some minimum level of security. And so it really came out as the requirement for a federal governmental agency to meet this minimum level of security. And what's interesting is this minimum level of security now requires RASP and IaaS. Enterprises, as I mentioned, aren't required unless you are contracted with the federal government. But a lot of enterprises like to have the same level because they find that the standards being developed by NIST, this isn't the only one, by the way, there are other standards that NIST produces for security and for cybersecurity and for the federal governments in other areas as well. But enterprises find this is a reasonable and good framework to adopt. And that's why, as I mentioned, 30 to 50% of enterprises actually use this as their framework and use this as their requirements. Okay. All right, I think that's it for questions. I don't see any new ones popping up at this point. Sid, did you want to move on to the next talk?
Yes. Thank you for that great presentation, Timothy. Let's move on to the third one and the last one for our day by Manish. So Manish, the floor is yours.
Thank you, Sid. Welcome, guys. Let me just start my screen share. And while that happens, are you guys seeing my slides?
It's still loading. Don't see. Okay, now we see it.
Awesome. So my name is Manish. I work, I've been in the security space for quite a while, security and privacy, of course. Before I start, just a quick caveat, as you can probably see from the background, both on my camera and the slides, I work for a company called Skyflow. Skyflow makes data vaults. This talk is not about Skyflow. I, in fact, don't even have a single slide on Skyflow. This is not a vendor talk. This is a talk about the architectural pattern that's called a data vault. As you will see, that the architectural pattern is not something we've invented. Other companies, very venerable, well-known companies, have been building this for years. So this talk is purely technical. So getting started with the talk, the data vault is a solution, but of course we are reasonable people. We don't want to start from a solution just because it's cool. We want to start from a problem. And the problem with data, of course, starts with what exactly your company, your business needs in terms of data protection. So we're going to start with a very cursory overlook of data security, privacy requirements. Knowing that there are data security requirements doesn't quite tell you what is the technical problem that needs to be solved. There's another fairly complex discussion that needs to be had about, like, how do you see this abstract problem? Not abstract, but how do you take the regulations and figure out how they apply to you and that the data your systems are managing? And then, of course, this is what I want to talk about is once you know what is the technical problem that follows from the general business problem, how do you go about solving it? And there also we want a structured approach. So I'm going to first start with, given that we know what the requirements, the business requirements are, let's figure out the technical capabilities or technical requirements we want in any solution that we want to use. Then we'll evaluate different approaches that and compare them against the requirements that we build. Spoiler alert, I'm going to basically say data vault is the right answer, as you probably guessed. But let's get started on this. So why should you care about data? Because you probably store data. Very few businesses don't. And if you store personal data, there's a whole bunch of different definitions of what is personal. I'll touch upon that. That's really not a technical question at this point in time. That's more a regulatory legal question. But there's different definitions of what is personal. But if you have personal data, you have obligations. So personal data and sensitive data are two things that I'm spinning out here. Personal data will give you obligations on reporting if there is a breach, for instance. You may be opening yourselves to fine, civil action, lawsuits. You can be opening your company to risks that go well beyond what the fines the Attorney General may place on you. You could be looking at the company going out of business. You could be looking at losing your job, et cetera, depending on how high up the food chain you are, I guess. But the short point is failure to meet the company's privacy and security obligations can lead to severe consequences to your company, to yourself, et cetera. What are the specific elements, of course, that depend on your business needs? The last bullet point I want to, this is sometimes gets confused. It's security and privacy are not the same thing. You can have security, very good security, without meeting your privacy obligations. It doesn't work quite the other way around. If you don't meet security, it's quite possible that you don't meet your privacy regulations. The obvious thing is like you can basically say, yeah, we don't use your data for anything, but your data is actually breached and available on the web. Well, you really can't keep any guarantees. So privacy is the larger problem. So I'm going to be focusing this conversation mostly on privacy, but you'll kind of be able to see that we are talking a lot about security aspects. Moving on to the question of fine, we have security obligations, privacy obligations, excuse me. What does that mean? I have like a whole bunch of data. So if I may just crudely draw a spectrum, you've got data that clearly falls on the left, which is may not be public, but could easily be public. For instance, the comments a user leaves on the public forum on your website, it's public by definition. User data that does not reveal anything about the user or very little about the user could be like time zone settings for the preferences for the user. You can aggregate a bunch of information, and that's not sensitive. So you can fairly easily share it within your company, at least. Maybe business sensitive, so you don't want to share it with your competitors, but in your company, you can freely use it because it's aggregated. For instance, on the right, I have stuff that is clearly sensitive. Regulations will make it sensitive, but even like if you just think about it from your own personal perspective, this is information that you would not want to expose outside. So this is clearly sensitive information. There's a bunch of stuff that kind of sort of varies. What about like initials on the name or partial name? What about IP address? In some locations, this is considered sensitive, identifying information, excuse me, to be more precise. In other jurisdictions, IP address is not a sensitive information, just a technical artifact. Zip code, well, on its own, probably not, because there's like gazillions of people who live in the same zip code. But that leads to other questions of like, what if I have zip code in combination with other elements of information? Location information. Now, if I give you like 10 digits of GPS accuracy, sure, it probably tells you exactly where my house is. But then those 10 digits might be fake accuracy because this is kind of just the center point of the zip code I live in. So does it really give you much information? There's a lot of complex questions to be answered. We will not go into them. As I said, these are not technical questions necessarily. You'll have to basically figure out from various combinations of like talking to your legal counsel or business experts in your company as to what your exposure may actually be. Just a couple of things I mentioned, accuracy and precision matter. I also kind of touched upon this, but often you may hold information that itself is not identifying, but if combined with other information, maybe combined with other public information, not your information, it can be identifying. There's lots of research on this, lots of incidents that you can kind of see. When I share the slide deck, you'll be able to follow these. You can Google these, you can take the links from my slide deck and read up more. There is a lot of de-identifying, de-anonymization concerns that privacy practitioners spend a lot of time thinking about. So there is a complex problem to be solved, which is what is sensitive. It varies by regulation, varies by what contracts you've signed with, if you're a service provider, with your business partners, what kind of terms of service you've given to your users. Out of scope for this discussion, but that's of course what feeds into the rest of the, that creates the technical problem that we're looking to solve. So important problems that you need to think about, but we'll assume for now that those have been solved and you've decided that there is a problem that needs to be solved. And you, as the technical experts, have been called on to find an approach to solving them. So now we get to the solutions part. Before we jump into a solution, let's see if we were to talk about a solution, what would we want from it? What are the requirements? What are the capabilities a solution should have? The first and most obvious one is you start with a design, or you start with an actual implementation that's running in production, and you want to secure it, you want to add privacy guarantees, etc. to it. You can't do it in a way that breaks the system, obviously. You did that, you may be the best security privacy expert, but you probably will be looking for somebody else who's hiring a security privacy expert. Obviously, we are doing this in the service of security and privacy. So you want to make sure that the system you build gives your overall system, your overall architecture, your company, the right support it needs to meet its security and privacy obligations. Very basic stuff in terms of security. You've got to have encryption. Some standards will actually explicitly say you need to have encryption. So therefore, it becomes a non-negotiable thing. And of course, why would you not want it? No-brainer. Obviously, encryption itself is just doesn't give you much. You need proper authentication, authorization, auditing for access for everything from how the customer added the data or accessed the data, plus administrative access you have to your data. Data lifecycle management also is important from the privacy perspective, because often you will have obligations on the user's ability to go delete your data. And this is also not as simple as it sounds. It's not just a question of like, just delete it. You need to delete copies of the data. You may have like backup copies. You may have copies in your analytical database. It starts getting even more complicated because a deletion obligation does not necessarily mean you need to delete every single copy of it. There are limited use cases like security forensics for which you are allowed to keep data. There could be legal, say there's a lawsuit that's pending, you may be required to not delete all of this data, but you are required in both these cases to segregate them away from normal business use. So you can't use it for analytics anymore. You need to keep it around for lawsuits, etc. Data retention, in some cases you have data retention requirements, for example. Moving on to a privacy related thing. Privacy basically doesn't say that you can't use data for, let's say, analytical purposes, but it does recommend or ask for use of this data, that's exposure of data that's limited to the use case you're trying to serve. So an example of this would be when a customer service is receiving a call and they want to verify it's the same user, might be good to give them the last 4 digits of your phone number, or maybe the area code. You get to pick, I guess, what the thing is. But this is a use case that needs partial access to that data, not full access to the data. So to meet your functional and privacy requirements, you do want a system that can expose only the amount of data that needs to be exposed in order to perform the function needed from the data. Sounds similar, but this is a different problem, which is sometimes you don't, surface minimization will sound similar to the 2D, but it's different because in this case, there are use cases where if you were to code this right, you would not even need access to the data. We'll see this in an example in a second, but it's kind of like when you're talking, to use an analogy, you have your configuration data. This could be everything from like, what is the host name your backend server runs on, or what's the URL for a third-party service that you hit. But then you have secrets as well, like the password, the API key to the third-party service you hit, the encryption key for some data that you encrypt before you dump it in your database. Well, those sensitive pieces of your configuration information belong somewhere else. They belong in a maybe a secrets vault, as opposed to the rest of your configuration information that could be sitting in a data bag somewhere. Well, a secrets manager that gives you the capability to not just store the encryption key, but to perform the encryption without the key ever leaving the secrets vault is giving you much better security than just somebody that can store the key securely for you. That's kind of what I mean by surface minimization. That applies to data as well, and I'll give you an example when we get to this. Obviously, you're storing data, you're processing data, so you want to make sure technically the system you're building or integrating with can store data, can scale to the data you're storing, can do it with minimal latency, reliability, et cetera, and obviously, like in anything in engineering, you want to lower your costs. You want to make sure that the total cost of ownership for acquiring, integrating the solution, for maintaining the solution is low. Those are requirements. Most of them are fairly obvious, at least at the top and the bottom. The ones in the middle are ones that, like 2, 3, and 4, 2 and 3 is where it relates specifically to security and privacy. If you have any questions on these, I can take them now. This is a good point to make sure that we are all on the same page. Otherwise, I can proceed, and we can, of course, take questions at the end as well. So I'll move on. Now let's talk about alternatives. Obviously, before I start, I'll just draw a very simplified, super simplified diagram, which should probably apply to everybody. You've got systems and processes that write data. You've got systems and processes that read data. I've split them into two different groups. Folks that actually need to deal with PII. That's my short stand-in for all kind of data that may have sensitivity requirements. So you've got systems processes that need the PII, system processes that don't need PII, and all of them are working off a data store or data stores that have a mix of sensitive and non-sensitive data. In my example, this is very simplified, just kind of like a cartoon, but cartoons are good to start with in terms of understanding. So this is kind of the system we're working with. And let's look at the alternative. First thing is you don't store or process any personal data. If you don't have data, you don't have to worry about it. Sometimes the best way to secure something is to not have to deal with it in the very first place. I'm not kidding here, but it sounds like I am, but I'm not. There are businesses that are built and have been very successful doing a whole bunch of functionality, providing value without needing to deal with personal data. Think of like Retail Me Not, for instance. There's lots of ways to build a business around this. Obviously, if that were the case, you wouldn't be listening to this talk. So I'm going to assume that we do have to deal with data. A different way to not have data is to use a third-party service that provides you the functionality without you needing to have the data. So a very obvious example is when you do payments. You could, of course, build a whole payment solution on your own that exposes you to a lot of data, a lot of liabilities, a lot of PCI, specifically PCI complications. But you could use something like Stripe, PayPal, Square, etc., for solving the same problem without you having to deal with the security and privacy burden here. Another example, you want to get a user's financial institution information. Well, again, this time you're asking the user for their bank username and password. Do you really want to have to store that? Why don't you use something like Plaid or Yodlee, etc., to get all of that without you having to deal with the data? So in other words, you can and absolutely should use this approach. But at the end of the day, I think if you basically say you will store no data, you are going to hobble yourself in terms of functionality. Data is, of course, the gold for our times. So you will need to have data, and therefore you will need to secure them. So what about just trying to go and bite the bullet and just harden everything? All the systems that deal with data, the systems that process the data itself, the systems that pass data around because they're a backup process, they're an API gateway that communicates payloads from the client back to the server that contains sensitive elements. Why don't you just go harden everything to the security and privacy requirements? Obviously, that's is theoretically a alternative you should consider, but practically speaking, not really. If you were to do this, clearly you would get exactly the same functionality. You have no break-in functionality, and of course, you wouldn't have any technical performance costs or latency, etc. But seriously, you're not getting any support to scalably build your security and privacy program in your company. And this has super high implementation costs and vigilance costs. Vigilance is important because no matter how good an effort you do, and that is a very high effort to make sure all your systems are secure and do a good job with privacy, having to make sure you can keep up with that is not really reasonable. So I don't think this is a practical solution. Theoretically, yeah, but practically, no. So what about using basic encryption? This is actually a good solution. The way it would work is you would take your data, and when you write your data writers would basically use a key to encrypt the data and write only the encrypted data. Now, folks who don't need access to the PII do not have access to the key. They can read the data all they want and process it, back it up, etc., etc. They just can't read the underlying email, and therefore their security privacy obligations are kind of gone. You've reduced the surface area. Folks that actually do need the PII do have access to the key, and good key manager will obviously provide you good encryption, but will also give you proper authentication authorization. So the right folks who can access the key are the only folks who access the key. They can give you good auditing capabilities depending on the key managers you use or build. So you should be able to get exactly what you want out of a key manager. So let's kind of evaluate this. So functionality will not break. Technically, yes, this encryption costs, but nobody really considers that really. So I'm going to say this doesn't exist. Encryption-based solutions are cheap to deploy and maintain. Very good, bunch of very good choices for you to use as key managers, etc. This gives you great security support. That's exactly what encryption key management is meant for. Encryption is not meant for privacy. So while it does give you some guarantees, some support for building privacy, particularly security, as we've spoken about earlier, it does not give you those use cases where somebody only wants partial information exposed. It does not give you the ability to execute workflows on your data. That's not what encryption is supposed to be doing, that you want to be able to do without needing access to the data itself. So it's a very good solution. It's not complete. So what we want to do, of course, is we want to take something like this, which is a good solution overall, and just kind of check the boxes that this one doesn't check. And if you do that, what you end up with is an architecture that kind of looks like this. So in this case, similar to the previous thing, you don't write the sensitive data in your database itself. You have your data writers write the sensitive data in something else that's called a data vault. What you write in your main database is a quote-unquote pointer. There's different ways, technical ways of implementing these pointers, but what you effectively get is a pointer to this database, to this data that is stored in the data vault here. Now, what this does is that somebody, just like in the previous case, somebody who does not need access to the underlying email itself, in my example, can read the database. They have a pointer that they can't make head or tail of because they're not allowed to talk to the data vault. They can do their work, like backups, API gateways can do their work without caring about what this email is. And therefore, they're out of your concern for privacy and security compliance. Folks that do need access have been authorized access by the data vault to get access to the underlying data. But now here's where the use case specific partial reveal of the data comes in. You can basically say, this use case, I just need to verify, get high confidence that this email address is for the right user. So I basically mask parts of the email address and return it. This guy does not have to be trusted to do the masking correctly. The data vault will do the masking and give you access to just the masked information. The other part, the workflow part. Now you want to basically send an email to this particular user with this pointer to the email address. Well, you could just tell the data vault, by the way, go to this user and execute this workflow that sends the email, and the data vault can communicate directly to your CRM provider with this email address without your system needing to see that email address. So you've gotten all the benefits of the encryption-based solution, but you've also gotten some additional benefits, the partial reveal and the workflow without any reveal at all. So this is kind of why a data vault becomes the right solution to solve this problem. I'm just writing this down here. It kind of gives you all, as you remember from the encryption solution, gives you all of those. It basically just solves the other problems. Now, data vault is, unlike key manager, is a kind of a new thing. So when you design your data vault, or if you choose to buy it from someone else, you should make sure that you demand that the performance overhead they add to your system is minimal and it's commensurate with what you're asking, the functionality you're asking for it, obviously. And you, of course, want to make sure that this is cheap to deploy and maintain for you. So if you can get all of that from your data vault provider, I think you've got the best solution that we have on the plate so far. This slide kind of is just a summarization of what I had. So when you have a copy of the slide, you can take a look at it. I won't spend time repeating that all over again. Now you may say, right, you know what, you presented this concept. Is this really a concept that real people use in the real world? And that's a great question. The answer is yes, it is. This is not something that we invented at Skyflow. This is something we build and sell. It's a complex product. Large companies have built data vaults for themselves. Many of them have built multiple data vaults because it is a cool and powerful concept that frees out the rest of the business to work in an agile manner without having to worry about concerns that are not their primary concerns. So this is a well-known concept, although not as popular as I believe it should be. So that's kind of the crux of my talk. I've, of course, just told you what the architectural pattern of the data vault is. I've not told you how to build a data vault. I've not told you that even if you got a data vault, how do you use a data vault? For instance, we figured out there's something happening to your data schema. It's changing. Instead of storing the email, you're storing like a pointer. Where do you take the email and convert it to a pointer? Do you do it at the client? Do you do it at the server? Do you have like a proxy or gateway do it for you? You have existing data. How do you migrate existing data into a data vault? So there's a whole bunch of questions that have not been covered today, of course, and hard to cover in 30 minutes. This is a complex topic. We've just as an example, we have like 40 engineers, and we've been spending 2 years building this. So and we are hiring for more. So this is a complex thing. Not all of this can be covered now, but the pointer here is to our blog. We do talk about everything from like solutions that are built on top of data vaults. We talk about how the technologies that are used to build data vaults. We talk about platform capabilities and things like that for the data vault. So might be good to check out our blog and stay in touch with them. These are of course follow-on talks that can and should be held. We will be publishing more blog items that would cover some of these topics. So that is it for my talk. Please connect with me, follow me. I will be posting follow-ups like the ones I mentioned about how to build data vaults and things like that as well. If you were impressed by this, I would highly encourage you to look into this data vault pattern for yourself. If you want to build, just want to run ideas, I'm more than happy to discuss your use cases and figure out how to build this and get the world to be better with data security and privacy. If you want to join us in building this, not just for your current employer, but for hundreds of companies that want to solve the same problem, we are looking for folks in pretty much any function in the company. So you can check out our job site as well. That's my talk. I will be happy to take questions now, or you can reach me on LinkedIn, Twitter, etc. as well. So thank you very much for this opportunity.
Do we have any questions for Manish? By the way, Manish, in the meantime, while people type questions if they have, I have posted a tweet for all three of our presenters today, and about your jobs thing. Thanks for mentioning this. That's actually very helpful. That proves actually very helpful for the community. It doesn't look like we have any questions. Should be able to wrap this up then. Let's give another minute. Okay, there we go. Can we access the recording and slides? Yes, Ash, we are recording this session and will be posted on OWASP Bay Area's YouTube channel. So stay tuned for that. It should be up by the end of Friday maximum. So those will be available there. Okay, so I just want to take a moment to give a big thank you to all our three speakers today for contributing their time, knowledge and expertise to us and the community. And thanks to all our attendees as well for joining us for this meetup. We have a meetup page, so make sure you follow it to stay updated with our future meetups. And as I just mentioned, we also have a YouTube channel. If you search for just OWASP area on YouTube, you'll get that. And we have been posting all our past talks just so that you don't miss on any of that content. And with that, I hope you all stay safe and stay in, and see you all at the next meetup. Take care.